Good morning, dear students. Welcome you all to the next lecture of the JCE Connect series of online lectures. We are studying the subject elements of civil engineering and engineering mechanics, in which we are dealing with module 1. So, the introduction to engineering mechanics part we have completed, first part of that. Now, in today's class, we'll be moving to the second part, which is resolution and composition of forces. Now, this part becomes very important because it is directly applied to the problems which we will be solving later. So, in today's class, let us start with the discussion of resolution and composition of forces. So, first is resolution. It is a process of splitting a force acting on a particle or a body into multiple components without changing the effect of the single force. So resolution, resolution. Okay, so in this process, what we do is a given force, we split along multiple components without changing the effect of the single force. Now, why we do this is generally the force is resolved along two components, one along the x-axis and other along the y-axis. So if a force is inclined, and as we are familiar with horizontal axis and vertical axis, which we have solved for a long time, we know x-axis and y-axis, and we can have a solution easily. So if a force is inclined, what we tend to do is we try to break that force along two components, one along the x and one along the y. So this process of splitting up a force is termed as resolution. So resolution is a process in which we split a force along x-axis and along y-axis. So if we have a force F, then its resolved component acting along x-axis is denoted by Fx, and the component acting along y-axis will be denoted by Fy. So this is what is a process of resolution of force. So we will use this process in the examples which we will be solving. So resolution is a process of splitting up of a force into two components, one along x-axis and another component along y-axis. So with this, what happens is we can easily solve the examples. So resolution is that process which makes the solution finding a easy one. So resolution, resolution together when we spell the word. So it is just a process where we are splitting up a single force. So if we consider a force F, we split that force along x-axis, that component will be termed as Fx, and we split along the y-axis, that component will be known as Fy. So now, when we check this figure, so I have two forces, AD and AB. Okay, I have two forces, AD and AB. From where those two forces have come? They have come from the main force F, which is acting along AC. So given force will be F, which is acting along AC, which is subtending an angle theta with the horizontal. So now this given force F, I want to split into two components, that is resolution. So I'll split along the x-axis, which is Fx, and I'll split along the y-axis, that is Fy. Okay, so now how we find what is the Fx and Fy component is shown in this figure. How to find the resolved components. Okay, so firstly, resolution, as I told, is a process of breaking off a force into its component forces. The components will be along x direction and y direction. So here we have a force F, which is acting along AC. Okay, which is acting along AC. Now that force F, what I am trying to do, I am trying to split along x-axis Fx, which is given by AD, and y-axis Fy, which is given by AB. I think the picture is clear, the figure is clear. Once again, I'll repeat, we have a force F which makes an angle theta with the horizontal. This force we have to resolve into two components, Fx and Fy. Fx component will be along the horizontal axis and Fy will be along the vertical. So here the horizontal is AD and the vertical is AB. So now when we consider the triangle CAD, okay, when we consider the triangle CAD from the figure, so I'm considering this triangle CAD from the figure. What we observe, definition of cos theta is, anyone definition of cos theta?
Adjacent upon hypotenuse.
Hypotenuse, right. Adjacent upon hypotenuse. So from this figure, your adjacent is AD, hypotenuse is AC. Okay, adjacent is AD and hypotenuse is AC. So we get Fx upon F, which comes out to be F cos theta. So similarly, when we use sine, okay, what is the sine rule? Sine theta is
Opposite upon hypotenuse.
Opposite by hypotenuse.
yes, right, opposite upon hypotenuse. So now for this opposite side is nothing but CD, but as it's a rectangle, CD is equal to AB. Okay, so opposite side is this side CD, which is same as AB. AB is given by Fy. So when we write sine theta, we get it as Fy divided by F, or Fy is equal to F sine theta. Okay, Fy we get as F sine theta. So one force which is given, which makes an angle with the horizontal axis theta, its component, horizontal component Fx equal to F cos theta, vertical component Fy is equal to F sine theta. So similarly, we can draw a diagram where the angle is subtended with the vertical. That is, the theta is made with AB axis. Okay, theta is made with AB. In that case, what happens is Fy will be F cos theta and Fx will be F sin theta. As simple as that. So what we have to consider here is with which axis the angle is there, that component will be cos. If the angle is with the vertical component will be cos. If the angle is with the horizontal component will be cos. So this entire process is called as resolution of a force. So this is asked for 6 marks. So definition and all will be 3 marks, the previous slide, and this slide which is currently there will be for 3 marks. So explain resolution of a force. So what is the process of resolution? Process of resolution is the one in which we split one single force into 2 components. One component will be along the horizontal axis and one component will be along the vertical axis. The one along horizontal axis, we name it as Fx. The one along vertical axis, we name it as Fy. So that was what is composition. Now, what will be the value of Fx and what will be the value of Fy? We find using this particular figure. So now in this figure, firstly what we have taken a force F, which is making an angle theta with the horizontal. So we have split this force into 2 components, Fx and Fy. So Fx is the horizontal component and Fy is the vertical component. Then we have named the rectangle ABCD. So by that we get the force is along AC, the horizontal component is along AD, and the vertical component is along AB. Then we take the triangle CAD. Okay, we take the triangle CAD, we apply sine and cos. Okay, so once we apply cos, we get Fs as F cos theta, and when we apply sine, we get Fy as F sine theta. So this is how we split a given force into 2 components. Now why do we do this is, as the force is inclined, okay, we analyze the things in 2 dimensional. So 2 dimensions means along x and y axis. So the inclined force we cannot analyze directly. So for that purpose, we need to split that force into 2 components, which we do along x axis and y axis. And by using sine and cos rules, we find the components. So in this case, fx will comes out to be f cos theta and fy comes out to be f sine theta. So as the angle here is with the horizontal, these are the things. Now it can happen that the angle is with the vertical. That means the theta is with AB. The AC force is making an angle with the vertical AB. So in that case, what happens is Fy will be written as F cos theta and Fx will be written as F sin theta. So what you have to remember is basically कौन से axis के साथ angle है वो देखना है. Okay, with which axis the angle is there, that we have to see. If the angle is with the horizontal component will be cos. If the angle is with the vertical component will be cos. Okay, so this you have to remember till module 1, 2 and 3. Up to module 3 this is required. Okay, up to module 3 this is required. So perfectly digest this part so that the things will be easy, and hopefully till then we'll see each other in the college also. Okay, so this is what is resolution of forces. Anyone has anything to ask or anything to put up, they can tell it. Because at the end of the class, I'll ask you all again what is composition and what is resolution once we finish discussing. Okay, Sagar, is it clear? Sagar?
Yes, sir.
Yeah, Akshata?
Sir.
Yes, sir.
Yeah, fine. Okay. So this is what is the process of resolution of a force. So here we are dividing a single force along two components. One is Fx, which is along x-axis. Other one is Fy, which is along y-axis. So here we have taken an example. A force F, which is represented by AC. It is split into two components. Fx, which is represented by AD, and Fy, which is represented by AB. We have taken angle theta, and using the triangle CAD, we have found out the component forces. So this is all about the resolution of force. Now, next part comes in is the, sorry, this is about 1 minute. I think forgot to edit the title here. Excuse me. Now we'll go to composition of force. It is a process of combining. Composition means combining. A process of combining a number of forces into a single force such that the net effect produced by the single force is equal to the algebraic sum of the effect produced by individual forces. The single force in this case is called as the resultant force, which produces the same effect on the body. The resultant force is denoted by R. So now, what is composition? Say on a body, a number of forces are acting, but for finding the solution, we want a single force. Okay, so we want a single force. 100 of forces are acting on a body, but we want a single force to obtain the solution. Now this process is called as composition. So in the process of composition, what we do is we find one single force which will produce the effect of all the forces acting on the body. So this process is called as composition of force. That single force is termed as resultant, and we denote it by R. So taking the same example as we have discussed in the previous class, if a car is broken down and if it is not running, we 3-4 people try and push the car. So we 3-4 people are number of forces. But in the meantime, the crane comes which will drag the car, and that crane is that single force which will be able to drag the car easily. So the forces applied by 4 people were the individual forces, and that crane was a single force which we can term it as an resultant, and it also produced the same effect, that is dragging the car. So resultant is that single force which will produce the same effect as produced by a number of forces on a body. Okay, so remember these two definitions. First was resolution, where we are splitting up a force, and composition, we are combining many forces to find a single force, which is termed as a resultant. So many times in the exams, this question is asked. In the internal also, this question is pretty much sure. 10 marks we ask it. Explain composition and resolution of forces. Okay, so 5 marks each thing comes in. So remember, composition means finding a single force, which we term it as a resultant. So for this, we'll take an example, and this is the core part up to module 3. Again, I am repeating. So here I have taken an example wherein x and y axis are marked. So you know positive and negative x axis, positive and negative y axis. So we have a force F1 which is subtending an angle theta 1, force F2 subtending an angle theta 2, force F3 subtending an angle theta 3, and force F4 which is subtending an angle theta 4. Okay, so here in this example I have taken all the angles are made with x-axis only. So now we have to do the process of composition. That means we have to find a single resultant. Okay, we have to find a single resultant. Now how we do that is, first we apply resolution, break individual force, then go for composition. You'll understand it as I go ahead. So now I'll take firstly the force F1. Okay, the force F1. So I'll split that force into components, F1 sine theta 1 and F1 cos theta 1. Now try and relate this image with that previous thing which we had done. Okay, try and relate this image with the rectangle where we had found out the two components. Okay, this is very, very important. So when we were back here, we have done this fx and fy. Fx was f cos theta and fy was f sin theta. So this was a process of resolution. So now when we go for composition, first we have to resolve individual force and then we can compose them. So this figure, remember or note it down if you have kept a pen and paper with you. Fx is f cos theta, fy is f sin theta, with the angle is with the horizontal. Now firstly in composition we have to apply a resolution, then compose the member forces. So here as we were there, F1 force, okay, which is in the first quadrant. What is happening with the F1 force? Horizontal component is F1 cos theta and vertical component is F1 sin theta. So similarly now, you'll get the next force F2. Okay, you'll get the next force F2.
F2 cos 2 theta, F2 sin 2 theta.
Yes, correct. F2 cos 2 theta, which will be cos horizontal or vertical?
Horizontal.
Horizontal. Yes, horizontal has to be cos. Correct. I was waiting. You have given the answer. That is very nice. So see here, this comes F2 cos 2 theta and F2 sin 2 theta. Now with this, firstly we'll understand how signs will be there. Okay. Now firstly we'll understand how signs will happen. Okay, I have marked positive and negative. So if we say F1, where is F1 going? Towards positive. So F1 will be positive. So where is F1 sin theta also going? Vertically upwards. So it also will be positive. Now this is the most important thing, and maximum students I have found that they get confused here. I don't know why. You have to see the arrowhead. Where is the arrowhead going? Towards which axis? Positive x-axis. So F1 cos theta 1 component will be positive. Now where is the arrowhead going with F1 sin theta 1? Up or down? F1 sine theta 1, where is the arrow going? Up or down?
Up.
Up, sir.
Up. So it has to
Up,
be
sir.
positive or negative? It will be
Positive.
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 Positive, sir.
Yes. Right. So when you have one force in first quadrant, both its components are positive. Okay, both its components are positive. So now, Manoj, are you there? Manoj Koppad? Manoj Koppad, are you there? Manoj Koppad, are you there? So if anyone is not answering, I'm removing them from the meeting directly. When I take the name, and if you are not answering, I'm removing them from the meeting. Anand?
Yes, sir.
Anand, you are there, right? So when we are speaking of second quadrant, we have written F2 cos theta 2, F2 sin theta 2. Which is positive and which is negative? Can you tell me? Yes, Anand, tell me. Horizontal is
Negative, sir.
negative. And vertical is
Positive.
positive. Very good, Anand. Appreciate your answer. Yes, this is how we have to take. When we are in the second quadrant, observe that the F2 cos theta 2 arrow is moving towards negative x-axis. So that has to be taken as negative. Whereas F2 sin theta 2 is again moving vertically upwards. It has to be taken as positive. Okay, it has to be taken as positive. Siddharth Pathar, are you there? Siddharth Pathar,
Yes, sir.
can you help me out with the force in third quadrant, F3?
Yes, sir.
Yeah, please tell me.
The horizontal
be-
minus x-axis is f3 cos theta.
Okay. And
The vertical is f3 sin theta.
theta. Where it will be going? Up or down?
The downward
Downwards.
minus
Okay.
y-axis.
Y-axis. Correct. Very good. Nice answer. Vedika? Vedika, are you there?
Yes.
So if we talk about fourth quadrant, what can happen? What you feel? Fourth quadrant, how will the force will split up?
F4 sine theta is negative and F4 cos theta is positive.
Positive. Okay. So now, when we see F4 cos theta, as you rightly said, it is positive, and F4 sin theta will be moving down, which is negative. So this is the picture. Okay, this is the picture wherein we get positive and negative axis. Okay, so we split up one single force first along its two components. So because in the process of composition of forces, firstly we have to resolve the individual force. And once we resolve the individual forces, now we have to compose them. Now this is an example where all the forces are moving away from the origin. Okay, this is an example where all the forces are moving away from the origin. F1, F2, F3, F4, all are going out. So similarly, you can get a scene where forces are coming in. Okay, forces are coming in. Now what you have to do is, same diagram you have to draw, but the forces coming in. Okay, as in practice. Just I'm telling, I'll explain you all in the next class, that stuff. Don't worry. You have to draw a diagram. Now F1, F2, F3, F4 are going outside, away from the origin. For practice, what you have to do is, you have to draw F1, arrow should be inside, F2 arrow should be again inside, means towards the origin, F3 arrow should be inside, F4 arrow should be inside. Let the angle be with the horizontal axis only, no problem. Then you have to find what will be the components. Okay, the next case what you have to do, keep the same diagram. But theta 1, theta 2, theta 3, theta 4, take with the vertical axis. Then find what are the components. Okay, such four combinations are possible. One I have taught you. Similarly, in one same diagram, angle with the vertical axis. Only what happens, where there is sine, it becomes cos. Then in the next case, you have to take the forces inside. I'll draw the image and give you all if you want. Not an issue, I'll put up on the group. But you have to scratch your head and try and find the components. So this is what is composition of forces. Now, using this part, what we say algebraic sum of components along x-axis. So which are the components along x-axis? F1 cos theta 1, F2 cos theta 2, F3 cos theta 3, and F4 cos theta 4. Okay, these are the components which are acting along x-axis. So we'll take the algebraic sum. Algebraic sum means taking the signs as it is. And as you all have rightly told, F1 is going towards right side, so this is taken as positive. F2 is going towards left side, so it is taken as negative. Again, F3 is going towards left side, it is taken as negative. And F4 is going towards right side, again it is taken as positive. So 2 are positive, 2 are negative. This is algebraic sum of components along x-axis. Similarly, we'll get algebraic sum of components along y-axis. So what will be that? F1 sine theta 1, vertical going upwards, so positive. F2 sine theta 2, again vertical going upwards, this is positive. The next is F3 sine theta 3 coming downwards, negative. And F4 sine theta 4 again coming downwards, negative. So this is how now we have got from the definition. So what was the definition here? If we go back here, what is the definition? It is a process of combining a number of forces into a single force. Okay, and we have now combined the forces. Okay, firstly we split each other, then along x-axis we have done the summation, that is combined. We have y-axis, we have combined, and once we get these two, the magnitude of the resultant is given by the formula R is equal to square root of summation fx square plus fy square. So what is this answer? What you get from summation fx? You have to put here as a square. What is the answer from the summation fy? You have to put this and square. So once you square it, the sign will not matter. Okay, this is the resultant, summation fx and fy. And where will be the resultant acting? It is given by the direction, that is theta. So theta will be tan inverse of summation fy divided by summation fx. So now R is that single force which will replace F1, F2, F3 and F4, and that will act at an angle theta. So this is what is called as composition of forces. So composition of forces is a process where we combine all the forces and replace it by a single force which produces the same effect as produced by the combination of all the four forces. So now in this figure we had four forces given to us: F1, F2, F3, F4. So first we applied resolution. We split those forces along x-axis and y-axis individually. Important thing here is sign. If that force is moving towards positive axis, sign is positive. If that force is moving towards negative axis, sign is negative. So we found out that for F1, which is in the first quadrant, both the components F1 cos theta 1 and F1 sin theta 1 are positive. Similarly, when the second quadrant was there, F2 cos theta 2 came as negative because it is moving towards minus x-axis, whereas F2 sin theta 2 is moving vertically upwards, so it came positive. So when we came in the third quadrant, both horizontal as well as vertical components, horizontal is moving towards left side or negative x-axis, and vertical is moving downwards, that is negative y-axis. So both the components were negative. When we came to the fourth quadrant, we found that x is again positive and y is negative. So we finished the first step, that is we resolved. Now we have to go for composition. How we go for composition? We take the algebraic sums along x-axis and along y-axis. Okay, we take the algebraic sum along x-axis and along y-axis. That is addition of all. So first force which was there was F1 cos theta 1 minus F2 cos theta 2 minus F3 cos theta 3 plus F4 cos theta 4. This gave us our summation Fx. Then similarly we found out summation Fy. Then comes the formulas by which we get that single force by which we can replace all these forces, and that formula is R is equal to square root of summation fx square plus summation fy square. And where will be this R acting? So this R will be acting at an angle theta, which is given by tan inverse of summation fy upon summation fx. This is what is the process of composition of the forces. Okay, take 1 minute, just go through the figure and everything, and then we'll discuss for 5 minutes, and I'll leave your class early today. Okay, so now I'll put one message in the chat box. Okay, I'll put one message in the chat box that we can try and discuss that.